What is value of cos between we got cos theta equals to T1 minus T2 upon T. Last lecture we stopped here, correct now?
Yes, sir.
Now this T1 minus T2 can be positive, can be negative. So if T1 minus T2 is positive and less than T, less than T means if T is 10, this is 9. What answer I will get? 1 or less than 1?
Less than.
Less than 1.
Less than 1.
So if T1 minus T2 is greater than 0, positive, but less than T, then can I say cos theta will be positive and less than 1? Positive and less than 1?
Yes, sir.
Less than 1 means acute or obtuse?
Acute.
Acute.
So angle of contact will be acute. That means it will be liquid wetting the wall of container or not wetting the wall of container. Wetting the wall of container, na? Acute means what? Wetting the wall of container, no?
Yes, sir.
And obtuse means it is not wetting the wall of container. If T1 minus T2 is less than 0, means negative.
Yes, sir.
But less than T again. Means this is minus 9, negative, but less than the magnitude of denominator. Hello? हाँ सर यहाँ सर स्टोर करतो नंबर आणि पाठवतो उद्या उद्या लेक्चर आहे ना त्यांचं 10 वाजता उद्या सकाळी लेक्चरचं 10 मिनिटं अगोदर हा चालेल ना द्या ना हा हा 1 मिनिट त्याने त्याला सांगा ना मला व्हॉट्सअप करण्यासाठी आता केलं तरी चालेल ठीक आहे 10 वाजता लेक्चर आहे मी 10 मिनिटं अगोदर पाठवा ठीक आहे but less than T, then angle of contact is obtuse. But if numerator is greater than denominator, what will happen? Is it possible? No, no, because cos theta cannot be greater than 1, correct?
Yes, sir.
That means the drop will be unstable. Unstable means it will not remain drop, it will become flat. The drop is not in equilibrium. Copy this 3 condition. One to 20 sums you all have tried, or after lecture you will try.
So few are left.
Achha. Others might be doing, I think 11 to 2 they will work on that.
So those problems are easy.
Let it be easy. Have you done till 20?
Yes, I just now finished.
Okay, because why I gave that 1 to 20 on your, because it is easy.
Done, sir.
Okay. Explain why there exists excess pressure on concave side of liquid surface. How many types of liquid surface you all have studied? 3 types: horizontal,
Okay.
concave and convex. Which liquid will give horizontal? One
So,
second.
we'll do one
And
second.
which is completely wetting the wall of container. Hello? हाँ बोलिए. एक 11 बजे करूँ क्या कॉल? Hello? Yeah. So there are 3 types of surface. One which is completely wetting, horizontal, partially then concave, convex. Okay. Now when you see from top, then that imaginary line, you will see dot na here. I will be able to see dot na of imaginary line on which force is acting. Okay. See what I am saying. If this is surface from the top, when I see that this imaginary line, force perpendicular to imaginary line per unit length is called surface tension. So it will be on this side, now like this dot I will be able to see now. And that force due to surface tension will be like this. Is there any excess force? Is there any excess force here? Up, down? Any excess force?
No, sir.
No. So only the pressure acting is atmospheric. Huh?
Yeah.
Correct. So that means this surface will have no excess pressure because force due to surface tension, they are cancelling each other. Therefore, only the pressure is atmospheric pressure. First case clear.
Yes, sir.
But if I draw force due to surface tension here, which is tangential, then it will have 2 components:
Of course, you have, sir.
vertical, horizontal. Horizontal, vertical, horizontal will cancel, na?
Yeah.
So where is excess force? In up direction or in
Upward
down?
direction.
Upward direction. Up means on concave side or on this convex side? Which side?
Okay.
Concave.
Concave. Similarly, when you draw force due to surface tension, which is tangential here, again I can have 2 components: horizontal, vertical. Horizontal, vertical. Horizontal will cancel each other.
This time downwards.
Yeah, but on which side? Concave side only, na?
Concave.
Concave side. So I can say thus there exists excess pressure on concave side of liquid. Draw this 3 diagram, then I will explain you. Just draw the diagram, then we'll explain one by one. Diagram done?
Yes, sir.
Okay, can I clear so that I can explain?
Yes.
Right. In case of liquid which completely wets the wall of container, the surface is horizontal. Hence, force due to surface tension has no component in vertical direction. Thus, there is no excess pressure. In case of liquid which partially wets the wall of container, has concave surface. Thus, force due to surface tension can be resolved into two rectangular components. The horizontal components cancels each other. Just complete till this, then I'm starting further. Thus, due to vertically upward forces, completed? Yes, completed till this. Thus, due to vertical upward forces.
No, sir.
Okay.
Done, sir.
Thus, due to vertically upward forces, there exists excess pressure on concave side of liquid surface. Shall I clear?
Yes.
One last paragraph in this. In case of liquid which does not wets the wall of container, the surface is convex. Hence, force due to surface tension can be resolved into two rectangular components. The horizontal components cancels each other, but due to vertically downward components, there exists excess pressure on concave side of liquid surface. Completed? Done, no?
Yeah.
Okay. Derive expression for excess pressure in liquid drop or obtain. It is also called Laplace formula. Excess pressure is also called as Laplace formula for elastic membrane. Meaning is same. What is basic pressure? Defined as
Force by area.
force by area. Correct. So what is force? Pressure into area.
Yeah.
Correct. Huh?
Yes, sir.
So force is pressure into area. And what is force into displacement? Is it work done?
Yes.
So work done can be taken as force into displacement, which is change in pressure into area into displacement. It is also nothing but change in internal energy by T into dA formula.
Yes.
So we will equate this. That means first we'll find what is change in area. Then we'll find what is increase in internal energy. Then we'll see what is work done in terms of force. I will equate. This is simple principle in this. So I'm just clearing the heading. Excess pressure means what? What excess we are talking about? Atmospheric से ज़्यादा उसको excess बोलते हैं ना. Otherwise, my body is also exerted by atmospheric. You are also atmospheric. अपना घर में भी atmospheric. Extra मतलब उससे ज़्यादा. Correct? Hello? Hello?
Yes, sir.
Yes.
So if we consider spherical drop of radius r having atmospheric pressure acted on it, P naught. So internal अगर Pi है, then Pi minus P naught will be excess pressure or not? Tell me. Hello? P naught is external. If suppose on this side there is internal pressure acting, ये Pi, तो जो दोनों का difference है वो excess होएगा ना. इधर excess pressure act हो रहा है ना इधर. So against this extra pressure, if I can move this surface, that means I am doing work or not.
Yes.
Okay. So let this surface increases by small distance or radius increases by small distance dr. So I will find initial area, final area, change in area, then work done. Okay, just draw diagram. I said first I will find initial area, final area, change in area, increase in energy. फिर work done, force into displacement करने वाला हूँ. Displacement dr है. Just you draw the diagram.
Done, sir.
Okay. Consider a spherical drop of radius r. Let P naught comma Pi be external and internal pressure. Let against excess pressure P internal minus P external, the drop B increased, the radius of drop be increased by dr. Therefore, initial area A1 equals to 4 pi r square. Final area A2 is 4 pi r plus dr square, which is 4 pi r square plus 2r dr plus dr square. Since dr is very small than r, therefore dr square can be neglected. Therefore A2 equals to 4 pi r square plus 2r dr. Okay, just copy this much.
Answer.
Okay. Everybody is done.
Yes.
Therefore, change in area, comma dA equals to A2 minus A1. So it is 4 pi r square plus 2r dr minus 4 pi r square. So dA equals to 4 pi r square plus 8 pi r dr minus 4 pi r square. So dA is 8 pi r dr. Therefore, increase in energy, comma du is T into dA. So du is T into 8 pi r dr. Copy. Done? Okay. Work done against excess pressure, comma dW is P internal minus P external area into dr. Actually, it is force into dr. So force is nothing but pressure into area. P internal minus P external area at that instant 4 pi r dr, equation 2. So from 1 and 2 we get du is same as dw. So T into 8 pi r dr equals to P internal minus P external 4 pi r square dr. Dr you can cancel, pi you can cancel, 1 r you can cancel. So we get P internal minus P external 8P upon 4R. That is P internal minus P external will be 2T by R. This is called Laplace formula. So excess pressure inside drop is 2T by R. Completed?
Yes, sir.
This is expression for excess pressure inside drop, or Laplace formula for elastic membrane. Note. For liquid drop, excess pressure equals to 2T by R. For soap bubble, if it is bubble, then two surface areas are increasing. Like this is spherical bubble, then this will increase plus this will also increase. So net area excess pressure we write as 4T by R.
Yeah.
4T by R. Please remember this, huh? But okay, just copy. अभी एयर ड्रॉप अगर होगा तो एयर तो टोटल अंदर एयर ही भरा है ना, so it will be only this area increase. So whether it is air drop or air bubble, always 2T by R will write. For soap bubble or liquid bubble, bubble then 4T by R, drop then 2T by R. But for air drop or air bubble, both it is only 2T by R. Because it is filled with air throughout. Air bubble, air drop or same. For air drop or air bubble, excess pressure equals to 2P by R. Done?
Yes, sir.
Explain. Okay, first capillary tube. Pipette, you have seen pipette? In the lab, you have seen pipette? Have you seen pipette in the lab?
Yes, sir.
So it is very thin tubes. So a glass tube with narrow opening, or we say bore, is called as capillary tube. When it is immersed in glass jar containing liquid, either liquid will rise in this tube or it will fall. That action is called capillary action and that tube is called capillary tube. So a thin glass tube open at both ends, having narrow bore, is called as capillary tube. Right. A thin glass tube open at both ends having thin opening or bore is called as capillary tube. Written, I think. Shall I clear it? Capillary action. the phenomenon of rise or fall of liquid column, the phenomenon of rise or fall of liquid column in capillary tube is called as capillary action. Right. Explain capillary action. Shall I clear? Heading, everything?
Yes, sir.
So if the liquid rises in the capillary tube or falls, depending upon the type of liquid taken in the container, is called capillary action. Now we have to prove it. When you move up, then pressure increases or decreases?
What?
When we move up, then pressure increases or decreases? Hill station, pressure is more or less?
So-
At hill station, pressure is more or less? No, less, no? That's why temperature is less, pressure is directly proportional to temperature. So as you rise up, then pressure becomes less. Suppose we are at sea level, so more height of air column is exerting the pressure. If you move up, then less will exert. ना?
Yes, sir.
ये वाला surface है, तो इधर pressure ज्यादा है ना? So for equilibrium, it will be pulled downward till the pressure is balanced. Na? So let us see this concept. This is liquid taken in a container. Consider liquid to be taken in a container which wets the wall of container. Inside this thin tube, curvature will be visible. If it is wide, then at the edges it is creeping. Here it is smooth, so we cannot make out that much. But if it is thin, तो ये ऐसा दिखेगा मुझे clear cut. So suppose I consider 4 points: A above the surface, B below, C and D close to the surface in the container. So let A, B be 2 points in capillary tube close to the surface. C and D are 2 points close to the surface but in the container. I think we all know pressure on same horizontal surface is same. No? We all know this. Pressure on same horizontal surface is same. Correct?
Yes, sir.
So pressure of A that is greater than B we know. B के line में D है ना, तो PB and PD are same. C and D ऊपर नीचे एकदम close. So PA will be greater than PC. मतलब सेम लाइन वाला लिक्विड कंटेनर का अंदर ज्यादा प्रेशर, कंटेनर के बाहर कम प्रेशर. तो इक्विलिब्रियम नहीं है ना सेम लाइन में. So it rises upward so that pressure decreases and comes same to same. That is phenomenon of Capel reaction, and that shows the rise in liquid column in capillary tube. फिर से एक बार देख लो. A का pressure on the curved side is greater, but B and C ये horizontal में ही है ना, B and D, तो ये सेम होएगा 2D. D और C up एकदम टच में है, तो it is same as C. So PA becomes greater than PC, which is not equilibrium. In same line, एक साइड का प्रेशर ज्यादा, एक पॉइंट का कम. So for equilibrium, it will rise upward. That is nothing but capillary action. Now you will complete this diagram, then I will explain it. Can I clear the diagram?
Yes, sir.
Okay. Consider liquid which wets the wall of container be taken in glass container. When capillary tube is dipped in the container, let A, comma B be 2 points near the surface. Near the surface in capillary tube, and C, comma D be 2 points near the surface but in container. Therefore, PA is greater than PB, but PB equals to PC equal to PB. Therefore, PA is greater than PC. Thus, for इधर तक लिखो पहला, PA greater than PC.
Sir,
Yes.
can you explain the reason once again why PC is equal to PD?
Because C and D both are on horizontal surface. All this above and bottom has got no meaning, no thickness. So C and D will be acted upon by same atmospheric pressure.
Yes.
Because on horizontal surface, pressure remains same, no, everywhere.
Yes.
That's why we wrote that. Shall I clear now?
Yes, sir.
This shows that surface will be in unequilibrium. Thus, liquid column in capillary tube rises upwards till, because ऊपर जाएंगे तो प्रेशर कम हो जाएगा, till pressure becomes same. Today we'll stop here. Now, I think tomorrow itself I will be able to complete theory. Completed?
Yes.
So that's all for today. We'll meet tomorrow as per our lecture, and as per that planner.